Welcome. On behalf of the team from University Polytechnica of Bucharest, together with Laura Ruse and Costin Carabaș, my name is Dragoș Niculescu. I'll be presenting our submission, Documents in the Air. If we look at Google Maps and we think about the main benefit that we get from them is in fact map annotation. These are objects placed on the map, points of interest, which are placed and curated by Google. And for many users, this is the main benefit of using these maps. Now we want to use the same thing indoors. So if GPS were available indoors, we'd want to have either a symbolic location or a Cartesian location, so we can attach points of interest to objects indoors. And of course, we are all familiar with post-its that we placed on the door fridge or on the lab door. And of course, they have a natural context in that they are documents placed at certain points indoors, and they function naturally even without maps. We don't need a map of the building because we find them wherever. I mean, somebody will find them wherever they are placed. So no positioning is involved in using of the bullet. Nowadays, most museums have QR codes, and if you think about the QR code, this is in fact a pointer to a document. So you have the context, the position, in fact, the location of the QR code, which will send you to a document, to a URL, where you can read things about the exhibit in the museum. So these are all examples of documents embedded in the environment, and this location-centric usage of documents, in fact, is not news. Has been proposed more than 25 years ago, before we had smartphones and GPS positioning in every phone. And as we mentioned in the example with the post-it, maps are optional, so we don't always need maps to embed these documents in environment, and many times we want to answer queries based on location. What are the documents around me? What is the closest document? But not always based on location, right? Many times, in fact, these queries are based on context, and context, of course, is natural for post-its. Now, the next question is how to provide this location-centric services. And one answer is indoors, we have to implement this indoor location system that will give us the equivalent of GPS. So we need a system to give us positions, locations, so that we can attach documents to them. Now, fingerprinting that uses Wi-Fi or BLE is one way to provide this indoor positioning. The problem with this is it's quite labor intensive, in that it has a training phase in which we need to associate signal strength in different points in the building with locations. And performance is something between 2 and 4 meters in recent indoor location competitions. Our premise in this presentation is whether we actually need location to provide this location-centric paradigm. And the main idea of documents in the air is to use signatures instead of location, instead of actual position. So this signature, which in our case is made of the Wi-Fi fingerprint, this is what we call signature, and this is specific to a location in the building. And we claim that it is in fact enough for us to attach a document to this signature. We don't need actual location. So most of the functionality that we mentioned can be implemented using this signature. Now, in addition to that, we need a measure of similarity between signatures, so that this will roughly correspond to distance. So we need to establish a function or correspondence between the dissimilarity and distance. And we don't need to translate a signature to a position, which is the main source of complexity for all those indoor positioning algorithms. We don't need training, don't need maintenance. We don't even need the ownership of the Wi-Fi space or of the physical space. I can go in an airport and collect a a Wi-Fi signature, even if I don't own the access points or I don't own the physical space of the airport. In a museum, on the other hand, of course, the museum probably owns the Wi-Fi infrastructure and owns the physical space. But as you will see, these are not in fact related to one another. Now, the middleware that we propose is based, in fact, on a very simple API. We'll harvest a signature, which is a collection of signal strengths to visible access points. So this will be the signature for now. And based on this signature, we can put a document into the database. That is, we associate this document with the signature. Or if we have a signature, we can ask what kind of documents are close to it. So this will be the query to get a list of documents. Where to place this document? It can be in the intranet if it's a service that runs on a well-known portal. It can be in the cloud. This is the implementation that we have right now. I won't spend time on the dissimilarity. I'll just show you the experiment, a small proof of concept that we have. And we propose this Bray-Curtis dissimilarity between two signatures. And the data that you see here is obtained from 85 points measured in a building. So we have 85 signatures, and then we take all pairs of points below 7 meters in this picture. So all pairs of points will compute the dissimilarity and the real distance between them. And as you can see, they have a roughly linear relationship between them. Now the question is, if we want to answer a query, what are the documents close to me? Since I don't have distance, that's our premise. We are going to answer queries based on dissimilarity. So in this example, I'm going to ask for dissimilarity below 0.25. So this is the horizontal line saying 0.25. As you can see, this will select a number of documents which are at different distances. But if I wanted, let's say, documents below 2 meters, the problem is that I will, of course, get some true positives. I will get the true negatives, but there will also be some documents which are misclassified. I will have false negatives and false positives. Now let's discuss just this case, this highlighted case at 3 meters. Let's say I want documents below 3 meters, and I selected a dissimilarity of 0.37 based on the criteria that I want to minimize the false negative. So I said that the recall is 99%, meaning that I have very few false negatives, this being the documents which are below 3 meters but are not being returned by my query. So this is my desire, not to miss anything under 3 meters. What happens is that I will get some false positive in this case, and for this particular line you can see that 1/3 of them are false positive. And in fact, 95% of the results are going to be below 4.4 meters. So the answer to this question is that I will return all documents below 3 meters and some documents below 4.4 meters. So this will be the kind of answer. I'll have some true positives, some false positives for this answer. So to summarize, documents in the air uses signatures instead of locations. So we want to avoid striving for computing a position or location in the building, which we know is expensive. And we use Bray-Curtis similarity so far to measure distance between signatures. We have implemented an Android app and a server, and we made different measurements in different buildings on obtaining 2 meters to 4 meter resolution. We are currently working on getting more measurements and more building, and in fact we want to evaluate our code on other public data sets. There are data sets using shopping malls and other universities for which they have ground truth of position. Again, our system doesn't use position, we just use it for reporting performance. The first other thing we want to include is other data sources such as BLE, magnetic and sound, which we believe will increase the resolution of of our implementation. Thanks for watching, and I'll be ready to take some questions live.